recording. This is a reminder, Class Connect sessions are recorded and distributed for learning purposes that are listed here. As always, be respectful, appropriate, and participate, but please don't share personal information during the class for your own security reasons. So we are on the February 22nd attendance ticket. Please give me a green check if you've got it open and ready to go. Open and just having it there. That way you're ready for the answers when they come throughout class. Just want to make sure it is working for everyone. Awesome, awesome, awesome. Looking good. Again, link is in the chat box. Password is right underneath it if you need it. So please go ahead, get that open. Good to go. Awesome. Not seeing any red X's, so it seems like you're all able to get it open, which is what I love to see. Okay, so we are on day 18 of quarter 3. We are finishing up week 4 because it's the weekend. Yay! So today we're going to go over 2 types of energy specifically. We covered them a little bit yesterday when we introduced a bunch of different types of energy, but today we're going more in depth with potential and kinetic energy. You have a tiny quiz at the end of class. It's actually only 3 questions, so you definitely have a pretty easy day in my class, at least. I don't know what your other classes look like, but my class is pretty easy today. So this is our unit. Remember, we're talking about energy. Today, again, we're taking a look at potential and kinetic. So we should be able to define those 2 terms today. We should be able to describe the differences between the 2 and provide examples of them as well. So definition, differences, descriptions, and examples. Okay, so that's where we are going today. So let's go ahead and at least start off with the definition of the 2. So the first thing is potential energy. We talked a little bit about this yesterday. Remember, potential energy is the stored energy due to an object's position, right? So you think potential, think position. They both start with PO, potential or position. In other words, the higher it is, does it have more or less potential to fall? Tell me in the chat box, the higher that an object is, does it have more or less potential for falling? Yeah, exactly. It has more potential, right? So really, when we think about this for potential energy, the higher the object is, the more it has. Okay? Smiley faces if that makes sense. Higher objects, potential energy, height are related to each other, okay? Now, once that potential energy gets released, right, once we actually drop the object, then the object begins to move, and motion energy is what we call kinetic energy. Remember, the word kinetic actually means motion. Just like we talked about in a previous class, kinetic friction is the friction for when an object is already moving. So again, kinetic motion. So once it starts moving, it becomes kinetic energy. So take a look here. This was the example we looked at yesterday where we have a dam, all right? And you can see which side of the dam is the water higher on, the left side or the right side? Which side is the water higher on, left side or right side? Tell me in the chat box. Yes, it's definitely higher on the right side, right? So if it's higher on the right side, does that mean that we have potential or kinetic energy on the right side? Remember, height has to do with which one, potential or kinetic? Yes, absolutely. This is going to be our potential energy. I'm just going to abbreviate that as PE because it gets super tedious to have to write potential energy 5,000 times. And as we let that water go through the dam, it begins to move due to gravity. And as it begins to move, what kind of energy is then that? Motion energy. It started off potential. Now it's moving lower. What is that becoming? Water in motion. Now what type of energy do we have? I got an answer from Israel. Everybody in the chat box. Doesn't matter if someone else already had the correct answer. You should still answer in the chat box so that you are also practicing. So we've let the water go. It begins moving down. What is motion again? What type of energy is motion? Again, we have the answers already on the board. What type of energy is motion? Yes, yes, yes. Thank you, Taylor. Thank you, Arrow. Thank you, Israel. Yes, it's going to be kinetic energy. Okay, smiley faces if that's beginning to make sense. Potential energy is when you're holding it, it's at rest. Kinetic energy is when it finally starts moving. Pretty easy. The basics are at least pretty easy. Awesome. This is actually number 1 in your ticket. Go ahead and fill in the blank with the word potential. Give me a green check when you have it saved. You have 30 seconds. Ready, set, go. Again, answer is in the red box. Go, go, go. Excellent. Waiting on a few more green checks. So let's get a green check from Amanda, Andrea, Bradley, Danny, David. Thank you, Andrea. Waiting on Dree, Dylan, Edwin, Cash, Mel. Let's see here. And use the green checks all around, please. Let me know that you're all set. Want to make sure I'm not leaving anyone behind. Looking good. Funny, Ireland. All right, here we go. So we talked a lot about potential energy just then and a little bit about kinetic. So let's go ahead and talk a little bit more about kinetic. Again, kinetic means motion. So kinetic energy is the energy of motion. Pretty simple at this point. You're going to hear it 1,000 times. So this means that objects that are moving, that have mass, that have velocity, velocity being like a speed, they are going to have kinetic energy. So you can see some examples over here, right? You could be bowling, you could be playing frisbee. Give me some other examples of kinetic energy, your body using kinetic energy. Tell me in the chat box. What are some other examples like sports or ways that you can move that are going to be using kinetic energy? Yes, running, exactly. So running is a prime example of an object with kinetic energy. Excellent. Other things? Okay, no worries, Amanda. I would definitely save the password and take pictures of the answers. That way you just have them and you don't have to wait for the recording. Cool. All right, swimming, yes, absolutely. Anytime your body is moving, you have kinetic energy. However, this even occurs even if you're kind of zoomed in. So if you zoom in on very, very small things like molecules or atoms, they can also be in motion. In fact, every atom around you is currently in motion. Even things that are solid, right, are actually, if you zoom in, they would actually be vibrating in place, and they actually do have a little bit of motion, even though we can't see it with our bare eyes, okay? But for example, when you melt ice, you can really see energy, those molecules begin to go in motion, right? Same thing with burning paper. You can see those molecules begin moving around a little bit more, getting faster and faster, and beginning to move. Smiley faces if that makes sense. Anything with motion has kinetic energy. So whether that's you or whether that's a molecule, you both have kinetic energy. Excellent. Please fill in the blank for number 2 with the word movement and give me a green check when you have it saved. You have 30 seconds. Go, go, go. Looking good. Waiting on a few more green checks. Let's get a green check from Amanda. If you were able to take a picture, I know your attendance ticket is being a little bit slow, but take a picture, give me a green check. Ashton, Bradley, Danny, David, Dree, Dylan, Edwin, Isaiah, Josiah, Cash. Let's see here, Arrow, green checks all around. Want to make sure everyone's good. Thank you, Amanda. Thank you, Ashton. Thank you, Danny. On top of it. Perfect. All right, let's keep going. Okay, so here's where it gets a little bit trickier. So we've kind of talked about, right, potential energy is having a lot of height. Kinetic energy is moving. But the crazy thing is that potential and kinetic energy actually very frequently exist together, okay? So what we're going to take a look at today is we're going to take a look at a couple different simulations. All right, so for this first one, we're going to see a skateboarder going down a ramp, and we're going to see what's happening with potential and kinetic energy at every single point. Okay, so we're going to start off with the top, the middle, and then the bottom. So let me go ahead and share this with you. All right, can we see my board? Let me know if you're unable to see it at all. All right, cool. So I'm going to start off with this one here. All right, and we're going to go ahead, take our skater and drop him. Oops, and here we go. All right, so we can see, again, this is what he looks like. So now I'm going to go ahead and actually slow him down, and we're going to go ahead and take a look at a couple different places where he is. So again, we're going to start at the very top. So looking at the very top, what is his energy? Is it kinetic or potential? Take a look at our graph right here. Okay, you might need to lean your head a little bit sideways. But at the very top of our ramp, what does he have? Kinetic or potential energy? I can probably, here, there you go, show it to you again. So tell me in the chat box, what is happening here? Yes, he has all potential energy, right? There's no kinetic energy at this moment. Take a look at his speed at the very top of the ramp. Does he have any speed at this point? Tell me in the chat box. Does he have any speed? No, he's actually not yet moving, all right? So what we're going to go ahead is we're going to go back over here, and at the top, his all of his energy is potential. So it's 100% potential energy. There is 0% kinetic energy. And in terms of describing him, right, his height is the highest possible height he could be, and his motion is the lowest it can possibly be. So he's got all the height, and no motion, which is why it's 100% potential, right? This is related. All height means all the potential. No motion means no kinetic. Smiley faces if that makes sense. Smiley faces if that makes sense. When we're looking at potential and kinetic, if they have height, that's potential. If they have kinetic, if they have motion, that is kinetic. All right, now let's go ahead and keep on going. We're going to take a look now at what happens when our skateboarder is at the center. So I'm going to press play here. And take a look here. All right, so take a look as he's halfway down the ramp. What is happening to his kinetic and potential energy? Okay, no worries, Parker. Save the password and then take pictures of the answers for today. That way you have them after class is over. You can also wait until the recording comes up, but you'll have to wait a little bit longer. Take a look at kinetic and potential. Describe what you see here in terms of the amount of kinetic, the amount of potential that he has. What is happening? Everybody in the chat box. Again, I can restart him where we started off with 100% potential. Now he's halfway down. And what's happening? Tell me in the chat box. What goes down? Don't just say anything goes down, right? There was something specifically that went down. What happened? Yes, potential energy decreased, right? It started off up here and now it decreased. What about kinetic energy? What happened to that? It increased. It went up. Exactly. So again, we have potential energy and now we also have kinetic energy. Not as much potential, but we do have more kinetic energy than we did when we started. So let's take a look at the description of what he's doing. So currently, what's his height? What is his height currently? Is it as high as it once was? Is it as low as it can go? What's going on with his height? Take a look at the height of the ramp, where he is on the ramp. Yeah, it's about medium, right? He's like medium halfway down the ramp, right? What about his speed? Does he have zero speed now? Does he have more speed? Does he have a lot of speed? What's going on here? Yeah, he's got a little bit more speed, obviously, than when he started, because when he started, he had 0, right? So let's go ahead, jump back over here, right? So he has about 50% potential energy, right? It was about half and half. So half of it was potential, half of it was kinetic. And in terms of the description, right, he had some height and some motion, right? Which again, these are related. So some height, that's why we only have 50% potential. Some kinetic, that's why we only have some motion, that's why we only have 50% kinetic. Smiley faces if that part makes sense. Smiley faces if that makes sense. Okay, Amanda, I would just try to close out of it right now. Don't worry about it. Take a picture of the answers, write down the password, and then you can finish it later. Because if it's giving you that much trouble, then it's just going to be a distraction and you're going to get frustrated, and I don't want you to feel frustrated, okay? So yeah, just take pictures and it'll be fine. You can't take pictures. Wait, what? Oh, wait, even if you can't take pictures, it's fine. You can just wait until the recording at 2 o'clock, and then you can go ahead and go through the answers at 2 o'clock, okay? But I really recommend at least take a look at where the answers are for class. That way, oh, you can't exit out. Okay. Okay, well, maybe just ignore it for now and just be in Blackboard, and maybe that'll be okay. All right, so yeah, just ignore it for now. Cool. All right, so let's go ahead and talk about what happens at the bottom. So let's go ahead. We're going to let our skater go to the very bottom. And what is happening now at the very bottom? Take a look at kinetic and potential energy. Describe what you see here for kinetic and potential. Tell me in the chat box. What are we seeing? Everybody, make sure you're participating. Again, it's helpful. It's not helpful if everybody else is participating and you're not, because then they're learning, but you aren't. So in order to help your own learning, you should be participating. Awesome. Yes. So we see something happened with our potential for sure, right? We started out with a lot, then we had only some, and now what are we having here with our potential? Yeah, so there's pretty much no potential energy here, right? Yeah, and it's all kinetic now. And he definitely has way more speed than he did at the beginning, all right? Or even at the middle. At the middle, he only had about half of the speed, and now he has a ton of speed. Okay, so take a look at this here. So let's go ahead, jump back over here. Okay, so we've got 0 potential energy. zero potential energy, and 100% kinetic energy. And in this case, could he go any lower? Tell me in the chat box. Did he have any height left over? Could that skater go any lower? No, he was at his lowest point, so he no longer had any height. He had no height, and he was as fast as he could possibly go. So yes, exactly, Israel. It was actually all his motion. When you're at the bottom of a hill, you're actually going the fastest you can possibly be going. Smiley faces if that makes sense. I know it's tempting to think like you're going down the hill. While you're going down the hill, you're going the fastest, but it's not until you reach the bottom that you're actually going the fastest. Okay, I just want to kind of correct that misconception right now. Cool. All right, everyone, let's go ahead and keep on going. So let's take a look at this. I'm going to give you some polling tools, and I want you to pay attention to this, okay? Sorry, let me give you different polling tools. So our first question is, where is the most potential energy? Again, potential energy, do I think of height or do I think of motion? Tell me in the chat box. Potential energy, do I think of height or motion? What should we be thinking of? Yes, we want to think of height. So take a look here and tell me, where does this roller coaster right here have the most height? That should be where the most potential energy is. Use your polling tools. Take a look here. Use your polling tools. Think to yourself, where is there the most height? That's also where there's going to be the most potential energy. Awesome. I got 4 answers. Use your polling tools, everybody. You should be participating. Let's pay attention. Let's work together. This will help us get through class, and then we have the weekend, so work hard. You don't need tools. You just need polling stuff. So it's up at the top. Your green check's turned into polling tools. Yeah, it's to the right of the raising hand. Awesome. There we go. Looking good. All right. Looks like the majority of us are saying letter A, and that is definitely true. So this one right here, the one with the most position, is point A. All right, so point A has the most potential energy because it has the most height. Smiley faces, everyone, if that makes sense. Okay, no worries, Amanda. All right, smiley faces, everyone, if that makes sense. Awesome. Thank you, Orlando. Thank you, Shoshana. Smiley, smiley, smileys. Looking good. All right, now, on the other hand, where do you think the least potential energy would then be? Okay, go ahead, try again. Tell me, where would the least potential energy be? Okay, this one's a little bit trickier. There's a lot of other points here. So take a look. Again, remember, potential energy means height. So where would I need to be looking if I want the least potential energy? Okay. Awesome. Oh, I can't even trick you guys up. Looks like we're getting lots of answers. Use your polling tools, everyone. Go, go, go. I have 9 answers, 10 answers. Again, the faster we participate, the faster class goes. Awesome. Yes, looks like we are all saying, well, not all, but most of us are saying point B. Point B. And that is definitely correct. All right, so point B right here is where we actually have the least potential energy. And can someone tell me, why does point B have the least potential energy? Tell me in the chat box. Why did you decide point B has the least potential energy? Think about what you were thinking. Think about thinking. Tell me, why did you decide this had the least potential energy? Awesome, awesome, awesome. I see an answer from Israel. I see Dorian typing, Ireland typing. Yeah, it's the lowest height, right? Basically, it has no height, right? So it has the least potential energy because there's no longer any height. All right, smiley faces if you guys feel good about that. Okay, so wherever we're the highest, that's the most potential energy. At the lowest, that's the least potential energy. Cool, cool, cool. All right. They are not all the same. I just said at the highest point, we have the most potential energy. At the lowest point, we have the least potential energy, which at B has the lowest point because there's no height to it. Okay, it's at 0 feet. All right, awesome, everyone. This is number 3 in your ticket. We're gonna answer the other half of number 3 in a couple slides. So please answer the potential energy ones. We'll answer the kinetic energy ones in a few moments. Okay, so you have 30 seconds. Ready, set, go. Please answer question number 3. Oh, sorry, I didn't give you green checks. Sorry, everyone. Give me a green check if we are good at number 3. All right, we have the 2 potential energy ones saved. Again, the kinetic energy ones we will be saving in a couple slides. My daughter is hanging out in the living room. She's playing right now. Right now, she is playing with her water bottle and some goldfish. Yep, she's always a goofball. Looking good, everyone. All right, let's go ahead and keep on moving. So here we go. A roller coaster, again, we talked about this, has both kinetic and potential energy as it's going downhill. So specifically, I just want to review really quickly what is happening to our speed. So I'm going to go ahead and share a different one here. Okay, oops. So I'm going to go ahead and show you a different simulation here. Okay, all right, so I'm going to go ahead and use a different one here. So here we go. Taking a look at this one. We're going to go ahead and stick our guy up here and play back and forth. Looking good. All right, so you can see he's going back and forth on this ramp. All right, sorry about that, everyone. Okay, so he's going back and forth on this ramp. So now I'm going to go ahead and do it in slow motion. And what I want you to notice is I want you to figure out, where does he have the max amount of speed? So take a look at our speedometer up here and tell me, where is his max speed? Take a look at the speed going up and down and tell me in the chat box, at what point is he going the absolute fastest? Where is he going the absolute fastest? Tell me in the chat box. Again, our speedometer's up here. Take a look at it go up and then down and then faster, 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 and then slower, 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 slower. Tell me, where is he going the fastest on the ramp? Come on, everyone. I need your participation in the chat box. Where is he going the fastest? Take a look at when the speedometer is at its max. The max is right about here, it looks like. So where is he when the speedometer is at its max? Yes, the lowest part, at the very center. That's actually where he's the fastest. All right, so at the very, 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 very center, right there, that's where he's the fastest. Smiley faces if you guys can see that. I'm going to actually pause it here. All right, so right here, this is the fastest he gets, and that fastest part, he is at the bottom of the hill, all right, bottom of the ramp here, okay? Now what I want you to look for is, when is he the slowest? When is he the slowest? So same thing, analyze what's going on here. When is he the slowest? Take a look at when it hits 0. What's happening when it hits 0? Yes, I got an answer from Stacy. Yes, right at the very, very tip top, he actually hits 0. So yes, on either side, right? On the left side or the right side, at the very tippy top, that is when he hits 0. So what I want you guys to think of is, you might not know this. Where is Vlad? Oh my gosh. Let me see if I can find another object here. Okay, so you guys might not know this, but when you throw an object up into the air, the moment that it changes direction, it actually stops for a moment. All right, so he's going up, up, up to the left, and suddenly he has to change directions to go back down. And for that split second, he actually stops. So it's the same thing is true when you throw an object in the air. So you throw this up, and at the very, very tippy top, it actually stops. Smiley faces if that makes sense. So even though it's moving fast, there is a split second where it stops. All right, cool, cool, cool. All right, so the next thing I want to take a look at is, what happens when he's about halfway down? Tell me, what's his speed like when he's about halfway down? Is he at his fastest, at his slowest? What's happening to his speed as he begins moving down the ramp? Yeah, it begins to build up. Is it at its fastest, though? It is faster, but is it the fastest? Remember, our fastest was about here. No, exactly. Cool. So let's go ahead and fill this in. So the speed at the top, right, is 0, right? It's 0 meters per second, 0 meters per second. So not moving. Okay, not moving. Now the speed at the middle, right, is faster, right? So faster, but not the fastest. And at the very, very bottom, this is the absolute fastest he can be moving. Okay, the fastest he can be moving. So that being said, where is the max speed, right? It's at the bottom. And what does that tell you? Yes, exactly. That's the flash. What does that tell you about the energy? What kind of energy must be at the bottom? Is that potential energy, kinetic energy, or both? What is happening at the very bottom of our hill? If he's moving the fastest he can possibly be moving. Yes, it must all be kinetic energy. So the max speed is at the bottom, so at the bottom, which means that it's 100% kinetic energy and 0% potential energy. There is no potential energy. Smiley faces if that makes a little bit more sense now. Again, kinetic energy is kind of a harder one to think of because a lot of times we don't realize that we're going the fastest at the bottom of a hill. You actually speed up more and more and more until you get to the bottom of the hill when you're going your fastest. Cool. All right, everyone. So let's go ahead and finish this part up. Tell me, using your polling tools, sorry, change that, polling tools, where must there be the most kinetic energy? Again, kinetic energy means motion. So take a look at this graph here and think about, where do you think there would be the most motion? Based on our little ramp activity, think about where's the most motion. Awesome, Mike. I see your answer. Go ahead and try using your polling tools, though, just so I can get a count of everybody. I appreciate it if you can go ahead and try and do that. It's the green check. The green check is now polling tools. Awesome, awesome. I'm getting so many answers. Love it. Get your answers up there. Work together. You are working with other classmates. Looking good, looking good. All right, let me go ahead and publish these up on the board. Looks like most of us said letter B, and letter B is correct. So the place that has the most kinetic energy is point B. And again, that is going to be right here at the very bottom of the hill. So at the very bottom of the hill is when you are going the fastest. Right? So that is always true. Point B, that is where you would be going the fastest. Why isn't it point D? Tell me in the chat box. Why isn't it point D? Point D is also a little bit of a dip, so it's tempting to say point D, but why is point D not quite correct? Awesome, got an answer from Stacy. I see Mike typing, arrow typing. Why is point D not quite as much? Okay, yes, yes. What was I saying? Sorry, yes. What was I saying? Okay, so, yes, right here, point D is not quite as much kinetic energy because it's not as steep, right? So it's not quite as low, not as steep or low, so you're actually not going quite as fast. You are going faster than when you're at C or E, but not quite as fast as B. Smiley faces if that makes sense. Smiley faces if that makes sense. Looking good. Now, on the other hand, where would there be the least kinetic energy? Use your polling tools. Tell me, where is the least kinetic energy? So point B, we definitely have the most because we're going the fastest. Where are we going the least amount of kinetic energy? Okay, again, think about where would you actually be going the slowest? The slowest. Your polling tools. Sorry, everyone. I got logged out of my other class, so I'm currently trying to troubleshoot that. All right, looking good. Let me see, what do we have here? I'm going to go ahead and publish our responses here. Looking good. All right, looks like we kind of have a split. So it looks like we're saying A, C, or E. Now, all of those are definitely at the tops of hills. But keep in mind that potential energy and kinetic energy are related. So where we have 100% potential energy, we actually have 0% kinetic energy. So take a look here. Where do we have 100% potential energy? Which would mean we have no kinetic energy. Where is the highest height? Highest height, 100% potential. Tell me in the chat box. Yes, point A is actually the least kinetic energy. So this one's going to be point A because at point A, this is all height, which means 100% potential, and no motion. No motion. So 0% kinetic. We said at the very top of our tippy toppest hill, we are going to be moving at 0 meters per second. Smiley faces if that makes more sense now. Smiley faces if that makes more sense now. All right, I know that one's always a little bit tricky. Cool, cool, cool. All right, looking good. So these are the answers to number 3. You will be using 2 of these again. So it's, again, the answers point B and point A, just kind of backwards. So go ahead and give me a green check when you have number 3 saved. You will notice that you don't use any of the other options for number 3. Green checks when you have this saved. You have 30 seconds. Ready, set, go. All right, looking good, everybody. Cool. All right, so what I want you to think about here for our last question here is I want you to take a look at position B versus position D. What I want you to think about is which one is going to have more kinetic energy, B or D? Think about B is a little bit lower on the roller coaster than D is. All right, so will it have more kinetic energy or less kinetic energy? Tell me in the chat box. What do you think? What is going to be going on? He's a little bit lower down the hill. The answer is more or less. Which does position B have more or less kinetic energy? Tell me in the chat box. Yeah, he's going to have more kinetic energy, right? Again, he's a little bit lower, and the lower this roller coaster is, the more kinetic energy you will have because you're going faster, right? So at this point, point B is going a little bit faster. So what does that mean for our potential energy? Remember, they are related. So if you have more of one, you have less of the other. So are we going to have more or less potential energy than position D? Yes, absolutely. We will end up having less potential energy, which should make sense because he has less height, right? So he's faster but has less height. Again, those two things are related. Smiley faces if that makes sense. Okay? So the lower you are, the faster you are, right? But the less potential you have. Awesome. Looking good. All right, here was our objective for today, right? We talked about potential versus kinetic, and we provided examples of them. I'm going to go ahead and send you your quiz really quickly. Remember, all of the answers to your quiz are in the attendance ticket, which you filled out using the yellow boxes. So you should be able to get 100% on your quiz. Do them side by side and then submit them at the same time. All right, thank you. Here we go. Here's your last word. Have a wonderful weekend, and I will see you all next week. Bye, everyone. Thanks so much. Here's your last word. Last word is roller for number 4. Bye, everyone. Bye, Israel.